flick of a switch, it goes from totally clear to completely opaque.
Instant privacy.
Exactly. Or maybe you're at home and the morning sun is just blazing in, but you don't want to mess with blinds.
Yeah, that can be annoying.
Well, this isn't science fiction anymore. It's real. And it's really changing how we think about our spaces.
It really is.
Fascinating world of switchable privacy glass. We're going to focus specifically on Polyvision smart glass. How is it shaking things up everywhere? From privacy, obviously, but also public health, advertising, even green building design.
And what's really interesting looking at the source materials we have is that this goes way beyond just privacy on demand for a window.
Right.
It's really a whole solution. It has
Yeah.
these deep implications across so many different industries. It's fundamentally changing how we design and build.
Versatile it is, and maybe why it's becoming such a big deal in architecture and design, sort of a look into truly adaptive buildings.
Exactly.
So let's start right at the beginning. What exactly is smart glass or privacy glass, fundamentally? And how does it do that instant transformation thing?
Yeah, that's the key question, isn't it? How
Yeah.
does it work? So Polyvision uses something called polymer dispersed liquid crystal technology, PDLC for short.
PDLC, got it.
Think of it like a microscopic sandwich inside the glass. You've got millions of tiny liquid crystal molecules just floating randomly inside polymer.
Okay.
Now, when you apply electricity, a voltage zap, those little crystals snap into alignment. And that creates a clear path for light to just pass straight through. That's your transparent state.
And when it's opaque?
You just turn the voltage off. The crystals immediately go back to their random scattered state. They block and diffuse the light, and boom, the glass looks milky or opaque.
And you mentioned it's instant. We're not talking a slow fade like some older tech.
Mm-hmm.
How quick are we talking?
Oh, it's incredibly fast. The specs say less than 80 milliseconds at room temperature.
Wow, that's faster than blinking.
Pretty much. And that speed is really important. It gives you that immediate control, that flexibility. It's totally different from, pulling down a blind or drawing a curtain.
No, that speed really does sound impactful. So what does that actually mean for, using it day to day? Because, yeah, unlike frosted glass or tinted glass that's just stuck that way.
Right, it's fixed.
This stuff adapts to what you need when you need it. You're in control.
Get the instant privacy, sure, but you also get this really modern, clean look. It fits right into contemporary designs. No need for bulky blinds or curtains anymore.
We clutter things up.
Totally. Plus, there's a safety angle. Laminated or tempered.
Okay, what's the difference there?
So, laminated glass, if it breaks, it holds together the car windshields. That's good for security. Tempered glass is much stronger, harder to break in the first place. Good for, say, busy public areas. So it's not just about looking sleek. It's making spaces safer and more functional too.
Okay, so we've got the basics down, how it works, the core benefits like privacy, looks, safety. Now let's get into where it's really making waves. It's showing up in some surprising places, right? Not just meeting rooms.
Absolutely. And one of the most fascinating areas is healthcare.
Healthcare. How so?
A predicament hospitals have with traditional privacy curtains, the fabric ones.
Yeah, standard issue.
Studies show they get contaminated really easily. We're talking germs, even drug-resistant bacteria.
Oh, seriously?
Yeah, they might get changed when a patient leaves, but they don't stay clean for long. It's a real risk for spreading infections.
Wow, okay. So the thing meant for privacy could actually be making things worse from a hygiene perspective?
Yeah,
that's a big problem. How does smart glass help there?
Well, that's where it shines. Polyvision surface is glass. It's non-porous.
Easy to clean.
Exactly. You can wipe it down with standard alcohol cleaners, and it's virtually germ-free. It removes nearly 100% of contaminants, unlike curtains that need constant washing and replacing.
That's huge for infection control.
It really is. Think about the impact on patient safety, but also operational costs, staff time. It allows for totally different patient room designs, more flexible, but still meeting really strict health and privacy rules.
And privacy rules are key in hospitals. HAPA and all that.
Precisely. Especially in busy places like emergency rooms. You need privacy now, but you also need staff to be able to see in quickly if needed. Smart glass lets you do both. Flip, it's private. Flip, it's clear for observation.
It turns a problem, the dirty curtain, into an actual solution.
That's a good way to put it, yeah.
Okay, that's a really powerful use case. But you said its impact goes beyond hospitals. What about, public spaces or retail?
Oh, yeah, retail's another big one. Think about storefront windows.
Okay.
Instead of just static displays, the sources can become dynamic projection screens.
So like digital signs, but the whole window.
Exactly. Retailers can project videos, images, text, maybe timed promotions, special offers. It turns the entire building front into this interactive advertising space.
Wow, that's blurring the lines between the physical store and digital marketing.
Totally. The building itself becomes part of the campaign, changing throughout the day or week.
And what about inside, like in offices? Is it just for meeting room walls?
It's great for that, but it's moving beyond it too. Any glass surface, really. A partition wall can instantly turn into a rear projection screen for a video call or a presentation.
So no need for a separate projector screen or whiteboard even.
Potentially, yeah.
Yeah.
And think about open plan offices. You get the collaborative vibe, but then flick a switch and you've got a private space for focused work or a sensitive meeting. That flexibility is huge for how teams work today.
Adapting the space on the fly, I can see that.
Right. Much more agile than fixed walls.
And what about for us, regular folks? At home or maybe when traveling?
Yeah, there are cool applications there too. In homes, some people are using it instead of a TV screen for a really clean, minimalist look, or just to divide up an open plan space, maybe section off a home office area.
Which is definitely needed more now with remote work.
Exactly. And in travel, there's this example from Taiwan's High-Speed Rail Museum. They use polyvision with touch sensors for interactive displays showing documentaries. And even in vehicles for advertising on windows or as smart sun shading, especially in panoramic sunroofs. Some versions have really good infrared blocking too.
Okay, you mentioned infrared blocking. That brings us to energy efficiency, right? This isn't just about fancy features. It's got some green credentials too.
Absolutely. That's a really significant benefit. If we connect this to the bigger picture, PDLC tech, like polyvision, gives you control over sunlight and glare.
How effectively?
Well, when it's in that opaque, translucent state, it blocks over 99% of UV light. That stops your furniture and stuff from fading.
Let's start.
But crucially, it also has a very low solar heat gain coefficient, less than 0.10 in that state.
Okay, solar heat gain coefficient, less than 0.10. Break that down for us. What does that mean practically?
It means when the glass is opaque, it's blocking over 90% of the sun's heat from getting inside.
90%, that's a lot.
It is. So think about summer. It dramatically cuts down how much your air conditioning has to work.
Yeah.
And by controlling natural light better, you might need less artificial lighting too. Big energy savings.
And how much power does the glass itself use?
Very little, actually. About half a watt per square foot when it's on in the clear state. That's less power than a typical solar panel generates.
Interesting comparison.
So yeah, it's moving towards this idea of adaptive buildings. Buildings that can react to the environment in real time, optimize energy, not just be static shells. It's a step towards, net zero design.
That's a really compelling angle. Okay, so it sounds great, but let's get practical. If you're an architect, designer, maybe even a homeowner thinking, yeah, I want this, what do you actually need to know to specify it or just to look after it once it's in?
Right, good question. This is key for anyone planning a project. The sources lay out a pretty clear process. First step, figure out the exact application. Is it just a window, a partition, a projection surface?
Because that affects other choices.
Exactly. Then you need precise dimensions. Measure twice, cut once, basically.
Always good advice.
Then you choose the glass type. We mentioned laminated for safety and sound control, tempered for strength. Or you might need an IGU, an insulated glass unit.
Okay, what's an IGU again?
That's basically 2 or more panes of glass sealed together, usually with a gap filled with gas. It's great for thermal insulation, keeping heat in or out, and also helps with soundproofing.
Gotcha. So lots of options depending on the need. It's not just one kind of smart glass.
Definitely not. It's tailored. After the glass type, you decide how you want to control it.
Right, the switching.
Yeah. Simple wall switch.
Yeah.
Remote control. Maybe a smartphone app. Or for more complex setups, motion sensors, or even tying it into a whole building automation system.
Okay, that sounds like it could get complicated.
It can, which leads to other points. You absolutely need to get the electrical requirements right for safe integration. And if you are using automation, you need to ensure compatibility with whatever system you have.
Makes sense. Any other factors?
Well, customization is possible. You could have logos or patterns embedded that appear or disappear.
Oh, neat.
For sound control needs, you look at the STC rating of the sound transmission class. Higher numbers mean better sound blocking. And, of course, always double-check compliance with local building codes and ask for the paperwork, the certifications.
Right, cover your bases.
Yep.
Okay, so you get it specified, installed. How do you take care of it long term? Is it high maintenance?
Surprisingly, no. That's another plus. You clean it pretty much like normal glass.
Really?
Yeah, use an ammonia-free cleaner or isopropyl alcohol, just rubbing alcohol with a soft microfiber cloth. The key is no abrasive stuff, no scrub brushes.
Don't scratch it.
Exactly. And if it's used outside, the sources say it's usually protected within a laminated unit or an IGU anyway to shield it from the weather.
Okay. What about lifespan? How long does this stuff last?
They state it's good for over 20 years indoors,
Mm-hmm.
but there's one key thing for longevity. It needs to be turned off in the opaque state for at least 4 hours a day.
4 hours off? Why is that?
It prevents the liquid crystals from getting kind of stuck in the aligned, clear position over time. Just lets them relax.
Okay. Like giving it a rest period.
Sort of, yeah. And it's tested for temperature, too. They recommend between -10 Celsius and 70 Celsius for exterior use and have specific guidelines if you need to store it before installation.
So it sounds robust, like a real long-term investment. But, with any tech, are there any like common hiccups or things people should just be aware of when they're considering it?
That's fair. Um, the main thing is probably the upfront cost. It is generally more expensive than standard glass or, say, putting in blinds.
Okay.
But you have to weigh that against the potential long-term energy savings and the reduced maintenance, like not needing to clean or replace curtains in a hospital, for example.
Right. The total cost of ownership.
Exactly. Integration can sometimes be tricky, too, especially with complex smart building systems. You need installers who know both glass and electrical work.
Good point. Anything else?
Just occasionally, some types might have a very slight haze, even when they're in the clear state. It's usually tiny, almost unnoticeable, but maybe something to check if you need absolute perfect clarity for a specific reason.
Minor points, maybe.
Often, yeah, compared to the advantages. And looking ahead, integrating this with AI, smarter home systems, maybe even generating dynamic content on the glass itself. The potential is just going to keep growing. It's making our buildings smarter.
Wow. What a deep dive. We've really covered a lot. From the basic science to these groundbreaking uses in hospitals, shops, offices, homes. It's clear Polyvision Smart Glass is way more than just a privacy trick. It's offering real solutions for hygiene, advertising, energy saving, flexible design. It's adaptable, it looks good, and it's genuinely transforming our spaces.
And I think connecting it all together, it shows smart glass isn't just some niche gadget anymore. It's becoming a strategic choice for architects, for builders, for anyone thinking about the future of spaces.
A future-proofing choice.
Yeah. It gives you control, flexibility, that touch of sophistication. It helps create places that work better for people, balancing that need for openness and seclusion while also being smarter about energy and maintenance. It's about buildings responding to us and the environment.
So as you've been listening, what really stands out to you about this tech? Maybe it's that germ-free hospital room idea. Or perhaps your office window turning into a screen. Or even just the energy savings. The next time you look at a simple pane of glass, maybe pause and think, could this do more? Could it be a communication tool? A privacy shield? An intelligent control for light and heat, all just with a switch? What possibilities does this spark in your imagination?